until January this year. Currently, I am also a professor at Shiva University, and also starting to teach this again in another university very soon. I have been teaching this since 2012. 2012. That's about 13 years now. Now, um, we have 24 chapters in this course. Normally, for my students, I always advise them that they should never be scared. Chapter 2, chapter 3, chapter 4 are frightening. Let me be very real. These are the chapters that, with my experience, students want to run away. As I told you, I started teaching this from 2012. Chapter 5 going, they're happy. They don't run away. So do not run away. Just take my words. You are in good hands. Myself and my director, Salim, and the other guy, Charles, we are seasoned guys in the system. We will be able to generate the best knowledge that you need. Now, with medical terminology for central service technicians, you might be wondering, why do we need medical terminology? Central sterile. After all, we are not physicians. We are not surgeons. So why do we need it? That is an obvious question. But it is true that we are not surgeons, but we help the OR. The operation room cannot survive without us. Donald Trump is our current president of the United States. He can never have a surgery without SPD techs. That tells you how critical it is. So we need to prepare the instruments or the instrumentation so that they'll be ready to be used on, whoever wants surgery. Now, these are our learning objectives. These are our learning objectives. Explain the importance of medical terminology for central service technicians to identify the various elements used in medical terminology. Now, the objective number 2, I'll be spending a lot of time on that because that is where the actual work is. Discuss how medical terminology can refer to the human anatomy, disease process, surgical instruments, and surgical procedures, and understand medical terminology used to refer to surgical procedures in surgery schedules, and understand the importance of medical terminology for service quality in the operating room. So this, to be able to master and to answer these questions. The next slide, the next page. Can I? Okay, very good. Yeah. Whoosh. Okay. So now, let's go straight, trying to understand the things in healthcare organization that guide the work. And we have ARON, something we call the Association of Perioperative Registered Nurses. They are one of the key agents of organizations or agencies that guide.
Oh, I'm sorry to interrupt. I see that you are having a little bit of network issue. Maybe if it will, I see that you are having a little bit of network issues.
Okay.
If it will help, can you turn off your video? That might increase your bandwidth and help, to go smoothly.
Okay.
So guys, I see, I know everybody has seen him, and it's not fair that most people have turned off their cameras while you are looking at us. Anyway, that's just a choice. So let's endeavor to have him, since we've seen that, we've noticed that he's having a little bit of network issues. If he turn off his camera, that would improve the bandwidth and ensure, smooth or enable smooth transmission. All right, Prof.
Yeah. Okay. Yes, I did that. Yeah. Thank you. Sorry about the internet issues. Yeah. So we see the word start over here, start. In SPD, when you hear the word start, what does it mean? We are going to understand all this. I don't want to jump straight to, putting fear in you, but then I want us to just go sequentially. Now, let's go to the next slide, please. On next page. Okay. Now, there are, sorry, we have three word elements. Just as humans have names, medical terms or the terms used in the medical field, we can dissect them or we can divide them. We can't dissect or divide them. Some have three word elements, some have two, some could be one. But there are three word elements that we are going to study. Now, summarize this. But let me begin from some history. Most of these things come from Greek and word element. Greek and Latin. In English, some of the words you speak come from, have their origin from Greek or Latin. So word elements or medical terms in the medical field also have some of these things. Now, there are three, and we call them the prefix, roots, and the suffixes. Prefixes, roots, and suffixes. Now, I don't know if you can see my cursor. If you can see my cursor, when you see prefix, roots, and suffix, that's because, site or for R, and R comes for S. That's the sequence. So in case you forget, just go by ACD up to P, the prefix, R. Let's begin with the prefix. Before I talk about the prefix and suffix, I want to talk about the roots. Remember very well that the prefix comes before the root, and that the suffix comes after the root. There is no word element in this world that has no root. Take my words. There is no medical terminology that has no root. It has a root. It may have prefix in addition, or suffix in addition, or the three in addition. The two. But you can never have prefix and suffix without the root. Let's begin with the root before I begin with the prefix. Now, the roots. You see, the gives meaning. For example, if I mention my name, is Michael Black? Is Michael White? Is Michael Green? So there must be Michael. So the Michael is the mention the root of Michael. I'm using my name as an example. If you are more information that we need to be able to understand the root. So the root word element is what we call, the primary meaning. It gives a primary meaning, what exactly the word is. For example, Michael. For example, Michael.
Mike,
have the suffix.
Mike,
Yeah.
it looks like
yes.
is breaking up a lot, and I'm sure
Okay.
people are missing out on a lot of things. I don't know if you join through phone also, so that
okay.
yeah, looking at our screen, maybe that will help. Call through
Okay.
phone.
Okay.
That was sent to you. Try calling through phone and let's see if that will improve. Guys, I believe you agree with me.
Yeah, I wanted to talk about it now. Same thing.
Okay. Yes. Okay. All right.
Because this is an interesting topic, and you're gonna love it, and it's very important. If you pay attention well, but the network is not helping you. So
Yeah.
you can join with your phone also, and
Okay. Yeah.
yeah, and mute one of the devices so that
Okay.
yeah, you can get this done.
I'm a little confused. Is he doing chapter 2 or 3?
Chapter 2.
Okay.
Can everyone hear me?
Yes.
Much
Okay.
better. So now mute your
Loud
other
and clear.
computer so that you can
Yeah.
do the phone and we can hear you.
Yeah, correct. Yeah. That one is on mute. The one from the computer is on mute. Yeah, thank you.
Okay, great.
Yeah. So I think there's an echo. Let me put this here. Hold on, guys. Yeah. Okay. So in case you have lost because of the bad network, I was talking about root, prefix, and suffix, and I said it is very easy.
Sterile processing. NP technicians require.
Yeah, thank you. The prefix, root, and suffix. Now you just have to, ABCD up to Z. P comes before R, and R comes before suffix, and that is the sequence. So in case you forget, just A B C D E F G H up, up to Z. Now, I was trying to say that there is no medical term in this world that has no root, but there can be medical term without prefix or suffix. And take my words. Now, the root gives the primary meaning of what we are talking about. And I was using my name, Michael, as an example. Now, if I mention my name right now, Michael, all of you will be waiting to hear something more. But when we say Michael, everybody knows that it's Michael. It's not Amda. It's not Taha. It's not Shania, but it is Michael. So Michael is the primary meaning. Now, you'll be waiting to hear something about Michael. So the prefix will say something about Michael, then the suffix will say something about Michael. Now, both the prefix and suffix, they modify or they alter. For example, if I say around Michael, good. Now, we begin with the prefix. Now, for example, I say around Michael. Well, or beside Michael. Then you understand more that, it is beside Michael. So the Michael is the root. That is the key. There can never be a medical term without the root. But what about Michael? Is he around Michael? Is he beside Michael? Is he inside Michael, endo, or beside, near, etc.? So the prefix modifies, or in other words, it throws more light on the root. It throws more light on the root. So you can see, comes before the root. I'm reading under prefix word element. Comes before the root. When added to a root at the beginning of a word, the prefix can alter or modify its meaning. So you can never have a medical, terminology without a root, but you can have, of course, without the prefix or the suffix. We'll be seeing a lot of examples, and they throw more light. They explain. So Michael is the root, but where around Michael? Is he inside? That's endo Michael. The moment I say endo, E-N-D-O, endo Michael, then everybody in the class here knows that, it is inside Michael. Beside Michael, around Michael Perry, then we know. All right, let's go down to the next word element. Let's come to the surface. Now, the surface comes after, in fact, the surface is the last one. Again, go by your A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P.
QRS. So they're in the sequence. So the S is the last one. The suffix. The suffix also comes after the root. Now, the suffix performs the same function as the prefix. It also modifies the root. It can alter or throw more light. If I say modify, I mean, to give more understanding, to throw more light on it, for us to understand it better. Now, let's go down. So, okay, well, let me read that. Comes after the root. When added to the root at the end of a word, the suffix can also alter or modify its meaning. For example, the medical term for the suffix that means inflammation is itis. So, for example, we say Michael. What about Michael? We say Michaelitis. Michaelitis. So you see, inflammation of Michael. So it's making an, that's trying to generate a better understanding. Or peri-Michael, around Michael. So the peri-itis, these are all, so the peri is the prefix, the itis, perimycitis, perimycalitis, meaning that inflammation around Michael. I'm just giving an example for you guys to understand it. So the Michael, which is in the middle, is the root. That is the reason I said you can never have a medical terminology without a root. It is the fundamental. It is the fundamental. Then you can either have prefix or suffix. Yeah, let's go on. All right. Let's come to the combining vowels. Let's come to what we call combining vowels. Now, pronunciation. Pronunciation. Sometimes, words are modified. And we can have, normally, if you remember your vowels in English, you have A, E, I, U. I think there are 5. A, E, I, O, and U. Correct. These are the 5 vowels in English. And normally, when a word begins with that, we begin with the word, or we say an orange, an elephant. Now, we have listens. Sometimes for the sake of pronunciation and writing grammar, to be able to pronounce, a vowel can be added or dropped. This is just to make it very easy to pronounce. It is just to make it easy to pronounce or to write. We'll be seeing some examples. So, of special note, with the term pericarditis is that the O in the root, cardio, is dropped, as you can see. Now, those of you who don't have the textbook, I'm advising you to have it as, my director said. You just have to have it. It's very, very important. I don't see how you can pass this course without the textbook. So try to have it. Okay, let's go next. Now, these are some examples. Here, we have prefix, root, suffix, and then we have the word element. Now, the first one we have is hemi. Hemi. Hemi means half. Atro is joint. When you go and see your doctor and you have, let's say, bone issues, they'll tell you to go and see the orthopedic doctor. Orthopedic doctor. Orthopedic doctor. Well, this is atro, and it's also about joint, and all forms fall under, orthopedic anyway. So the root here is atro, which is joint. But which part of the joint? Where? What is happening? What is happening to the joint? So the prefix comes to help us. Hemi, atro. Then plasty means surgical restoration. So hemiarthroplasty, that's the word. Now, so when we give you this word, hemiarthroplasty, you should be able to break it down by finding out the root. It's always good to find the root. That's the athro in the middle. Then the plasty is at the way, at the end of it, which modifies the root. So it is modifying the root in the sense that it is telling you that they're going to treat somebody to restore somebody's joint. And it's about half of it, hemiarthroplasty. And you have it over there. Then you have the other one is gastrostomach. Normally people who are obese, surgeons think that they eat too much and therefore they must reduce their food consumption. Sometimes they try to remove part of their stomach so that if you can eat two balls of kenkey to be full, now you can only eat one ball of kenkey to be full. In doing that, they remove half of the stomach. So you say hemi, half. Gastro is stomach. Ectomy, which is a suffix, means surgical removal. So hemigastrectomy. So the moment you are in sterile processing and they bring the schedule for tomorrow, you see hemigastrectomy. You know that, oh, okay, they are going to remove somebody's stomach. And then what race? Well, general. This falls under general procedure. General, it is stomach. So deep surgical tray is very important. Well, I'm not going to those things for now because you have no ideas about the trays. But I'm just trying to say that you hearing this, you know that they're going to remove half of somebody's stomach. And most often, it is for those who are very, very huge, very, very like big obese, and then they want to reduce their food consumption. Another thing is here. Then you have colon over there. That's the colon. So normally when I get to this slide or this page, I ask my students, now I want you to use it as a practice. Go home. Para is also over there. Para means beside or near. So para Michael, para Amda. Para Amda means near or beside Amda. Para Yusuf means beside Yusuf. Para Michael, near. So these examples are there. And then we have the roots. Just get yourself familiar. The good news is that with my experience teaching this over the years from 2012, normally you are going to get about 2 or 3 questions on this chapter. The exams is not too much on this because the actual work we do is from chapter 6, 7, 8, 9 going to the end. These are things that they want us to know. So normally about 3 or 4, 2 or 3. But remember, you need 105 questions to pass. Out of 150, 105, 105 questions to pass. So 104 you fail. So even if 2 questions are coming from this chapter or 3 questions are coming from this chapter, it is still very, very important for you to spend some time to get yourself familiarized with all this, Yes. So let's go to the next page. All right. So we have some examples also here again that, pertaining to, and this area, it is only by practice. We can go through everything, I bet you. But then if you don't practice, you are not going to understand. You see, AC, figure 2.2, surfaces that mean pertaining to IC, cardiac. It is cardio. But then the O, remember the commanding vowel, the O is dropped. We talk about that right now. Look under meaning. Figure 2.2, we are talking about the first one. You see, pertaining to the heart, O in cardio is dropped, you see. So sometimes for the sake of pronunciation and writing a vowel, we call it the combining vowel. So this is a very good example. Cardio, the O is dropped and make it cardiac. It's about heart. So AC means pertaining to AL, dermal, pertaining to the skin. Dermatologist. When you go to see your skin doctor, we call it dermatologist. Derma, skin. Dermal. IC, hemi, pertaining to blood. Then eel. Then we have the samples over there. When it comes to 2.3, figure 2.3, letters in word elements may be dropped or added. There are a lot of examples over here. Proctor, look at the word proctor, the first one. Look under letters change. O is dropped. Then somewhere, when you come to when you look under that, O is added. So some places O is dropped, some places O is added. Just for the sake of combining vowel, this for the ease of pronunciation. Okay, let's go to the next page. Okay, here now 2.4. Common medical surfaces. Yes, this is where we have a lot of examples. We have a lot of examples over here. As you can see, algia, pain, neuralgia, nerve pain, side, like, in Ghana, we have weedicide, herbicide, insecticide. Anything that is side is to kill. Bactericide, you see, a substance that kills bacteria. So I'm giving a lot of examples: herbicide, insecticides, weedicides. We are very familiar with this, things. Those of you from Ghana, I believe most of you are from Ghana. Yes. So side means to kill, and then we have area also the blood, genic, gram. It is inflammation. We saw that already. Yeah. Then we have Rafi, etc. So these are all examples. And as I said, this area, you just have to spend some time to get yourself familiar. Yes. Now, the next one is 2.5, common surgical suffix. Now we are on surfaces. Size, to cut. Size is to cut out. So normally, this area, there is no specific explanation. You just have to, get used to some of these things. Ectomy. We met that already. Hemigastrectomy, we just met it. We just met hemigastrectomy. So when you see ectomy here, it means surgical removal. Cystectomy, removal of a cyst. Then we have them as a lot of examples over there. Yes. Now, otomy. You see, we have ectomy, otomy, and ostomy. There are three of them. Very confusing. Now, this otomy, incision into an organ. So craniotomy. Cranio is a skull. I mean the head. Normally, when somebody is going to have a brain surgery or something, yeah, it is something we call craniotomy, cranioskull. Otomy means making an incision into an organ, which is different from ectomy, which is also different from ostomy. So there are three of them, and they are very confusing. But once you get yourself familiarized with it, we saw plasty already, surgical restoration. Arthroplasty, remember, we saw arthroplasty right now, not too long ago. So surgical restoration. Let's say somebody is going to make, let's say, with due respect to everyone, breast surgery or breast augmentation. It is a kind of, something plastic, because after that, they are going to restore to make things, look good. It's an example. So you see those kind of things, plastic, ending with plastic. Sometimes when somebody is involved in a vehicular accident, they can harvest an organ from one part or a tissue from one part and transfer to another part to restore the area. That's also called plastic. Rafi means to suture. Let's say something is torn and they want to, repair. So we call that, Rafi. Next page, please. Okay. Common medical roads. Let's come. Yes, right there. Okay. Common medical roads. So here also you can see cardio. Well, let me begin from the top. Adero, aero, atro, broncho, cardio. We have tons of them. Now, as students, I am not expecting you to master these things today. Let me be very real. I was like you when I was studying this. So I'm not expecting you that after the class today, you should be able to master this. It takes time to master, but don't throw the book away. Just spend some time. Tell yourself that, well, you are going to learn some rules today. So you begin to go through all this. Yes. As you see them, there are a lot. There are a lot. There are a lot. Tons of them. A lot of examples. Yeah. Understanding usage. Yeah. So basically, this is how these terms are used. Now, learning medical terminology can be an almost endless process. This means that it is every day. We never heard about COVID. We never heard about COVID. COVID came. The more diseases are coming, the more medical terminologies we are going to have. That is why this first sentence states very clearly that learning medical terminology can be an almost endless process, which implies that various body parts, procedures types, etc. So that is how it is. So we continue to learn. Now, there are some examples also over here, as you can see. Those of you who have the book, when you go to page 35, 35, and 36, you see these examples. Good. Yes. Now, anatomy. Let's go to let's go back to page 35. It's okay. It's okay. It's okay. Right there. Yeah. So you see some abbreviations. Now, it's also very good that you learn some of the abbreviations.
Excuse me, is it page 25 or 35?
Yeah, I was
No,
going to ask
35.
the same thing again because I don't know if I
That's
have.
the old book.
Oh,
I
Guys,
think that's the old
35.
version.
guys,
Mhm.
we are using the old book. We should have used the slide. I did indicate that we found that the slide needs to be worked on. So we are using the book, and you cannot have the slide of the new version. That's like a copyright issue. So that's why we are doing that. But it has the same content. It's just the page
Yeah.
numbers that change. So turn with me to page number. Let me tell you. I'll give.
The new one, they are using the new one, right? The 9th edition.
Yeah.
Yeah, the ninth edition.
Okay. Go to page 24. Go to page
Yeah.
24.
Yeah, page
those of you who
24.
have it, go to page 24. 24. 24. You see AAA,
Yeah.
ACF, ACL, AKA. So these are the abbreviations. For example, DNC, which is the popular surgery, the hospital, L&D. Those of you who are mothers here who have, gone to the hospital to deliver, you have heard about L&D, labor and delivery. So these are all, terms. So if you're using the 9th edition, which is the latest edition, which I advise everyone to have the latest edition, though, is 24, page 24 to page 25. Yeah, page 24 to page 25. Yes. Thanks for your question, Jahara. Thanks for your question. Yeah. All right. So let's continue. Let's go up. Yeah. Okay. Yeah. Anatomy of surgical. Let's go down again. There is nothing actually of much importance over here. Okay, it's okay. Now, here also there is no much talk about over here. What I said already is that you must try as much as possible to get yourself familiar to some of these terms, and case card and sample. Okay, yeah, let's go on. Yeah, it's okay. It's okay. It's okay. Come down a little bit. Yeah, it's okay. It's okay. It's okay. So, for example, I was saying that if you working in the SPD and they bring you the schedule, normally SPD gets the schedule a day before. But there is a system where SPD director, stamp director, managers can see the schedule about 2 weeks, 3 weeks, 1 month ahead. Now, for example, when you see Dr. Wells has TAH. So, for example, the moment you see that, you ask yourself, total abdominal hysterectomy. TH means total abdominal hysterectomy. I'm talking about Dr. Clark. 7 a.m. schedule, the patient being Mary Smith. So once you see these things, abbreviations, TAH, total abdominal hysterectomy, with BSO, bilateral samicophorectomy, bilateral, where they're going to remove the two ovaries. Yeah, they're going to remove the two ovaries. That's the bilateral samicophorectomy, total abdominal hysterectomy. The uterus will be removed. So the uterus, so Mary Smith, they're going to remove her, uterus, and also remove her two, fallopian tubes. So this is how this works. DNC, dilation and correct. Dilation and correct. You are 2 months pregnant, 3 months pregnant. You don't want to have the baby. They take it out. So TKA, ORIF. So all these things help you to understand, so for example, myself, when I'm working the SPD, once I see TH with BSO, I know that, okay, all GYN trace, all GYN trace must be ready, something like that. That's what it means. All right, thank you. Let's go on. So I think it ends over here. Yes. So conclusion is that, let me summarize this chapter. Now, we started this chapter today, chapter 2, by letting you understand that medical terminologies are very important to SPD techs. We are not surgeons. So why? But for example, if a surgeon or the ward calls, oh, I need cystoscopy tray, you know that you are not going into GYN area, you are not going to orthopedic area, you are going to urology area, you know the area to go. Now, we call something word elements, just like human beings. Michael, when you mention my name, Michael, so everybody will be waiting to hear, what about Michael? So Michael is a root word element. There are 3 word elements: the prefix, the root, and the suffix. The prefix comes before the root, and the suffix comes after the root. The root is in the middle. I also told you that there is no medical terminology in this world without a root. But there can, C-A-N, there can be a medical terminology without a prefix or without a suffix, but there is no medical terminology without a root. Because the root is the primary meaning. So Michael is the root. Endomichael, that is inside Michael. Perimichael, around Michael. We talk about that. Then we talk about the combining vowels. We said the combining vowel is so that for the ease of pronunciation, a vowel, A, E, O, I, U, could be dropped or added. And we saw some examples. We saw cardio, and then we saw cardiac. The O was removed for the sake of commanding vowel pronunciation. With this, we have finished with this chapter, which is very short. You just have to spend some time to go and study. Any questions for me?
All right, guys, thank you so much, Prof. Before anybody asks a question, what I would also add is that, like Professor had rightly indicated, chapter 1 to 4 is the most intimidating chapters in this course, or for that matter, this book, the course book. And what I always tell students is that sometimes you just have to read it and understand. Don't try to memorize it, especially chapter 3.
Yeah.
And the way this course is structured is that if you only read it when the question is posed, you would understand. By even just showing up, you would get at least 40%. And if the person is as good as Professor Mike, you get 60%, and the rest will be based on your efforts, right? If you read, like the book stated, medical terminology is endless. And for that matter, we don't expect, and even examiners don't expect that you know everything. That is why we didn't waste a lot of time or spend a lot of time going through that. We expect that you would do that at your own time. However, we know that some people are busy. They have other life commitments. and it's very difficult to juggle between stuff. So we put everything in a form of question and answers so that when you read and you practice, when you see it in your state board exams, it will be easy for you to understand. There's no gainsaying that if you do not do the practice quiz, and for that matter, the chapter quiz, guys, you are just wasting your time. Today when I checked, only like 3 people are still yet to do it. I assume that they got caught up in other things. They would do it before the end of the day, because today is Sunday. We are already going through we are now moving to the third chapter. If time permits, we'll be going through chapter 4, but I doubt, because chapter 3 is very much loaded. And
yeah, very long.
yeah, when we get to the other chapters, you understand that what we said, the first 4 chapters are the most intimidating. It's going to get better, and I'll just entreat each and every one of you to endeavor and persevere. Thank you, Prof. Let's continue
All right.
to chapter 3.
All right, thank you very much. So, chapter 3, anatomy for central service technicians. Anatomy. This is, biology. If you enjoyed biology in your high school or in your school, whatever stage, you are going to like this chapter. And again, the question comes again: why are we interested in this SPD or sterile processing? In principle, we are not, but remember, all the things that we are doing, we are not in veterinary. We are not in veterinary clinic. So everything is used on human beings. So this chapter, we are going to look at the skeletal system, muscular system, nervous system, endocrine, etc. Let me give you some basic understanding of this. When we say anatomy, we are going to look at the human composition, how the human being is composed. Human beings are composed of more than 100 trillion cells, and the brain alone is more than 100 billion, and all these cells come into contact to form specific things, and that's what we are going to study. Now, let's begin with the introduction. Well, many surgical interventions have developed to treat human body and enable it to heal. As I said, it's about the human body. We are not in the veterinary where we are going to talk about animals. So these are, human things. Now, anatomy and physiology. We begin with cells. We have cells, tissues, and organs. And please, I want everyone to pay attention, because I'm going to tell you something very critical when it comes to the cells and tissues and organs before you go to the systems. Now, there is something over here. They are the basic unit of life. The human body is made up of more than 100 trillion. I said that already. So any one of you there, I remember in August last year, I was teaching a class in upstate New York, in Ithaca. And there was one lady in my class pregnant. So when I got to cells and I said human beings have more than 100 trillion, then she burst into laughter. She was laughing. Then I said, what's wrong? She said, well, then she is double of that, because she's pregnant, Yes. So more than 100 trillion, and that is the basic unit of life. This means that when all the cells die in you, the human being moving, you also die. So life begins from the cells. So the basic unit of life, they vary in shape. Oh, thanks, for zooming it. Yeah, thanks for zooming it. I like it when it's zoomed. Yeah, it's okay this way. Now, they vary in size. Please, I'm going to explain this, and everybody listen to me. They vary in size, shape, and function. Let me talk about the shape and function. Now, our fingers are elongated, or our fingers are long. So the cells in the finger should have an elongated shape. Let's come to the eye. The human eye is like an egg, round, spherical, which means that the cells in the human eye will also be spherical. That is the reason we have here the varying in size are more interested in shape and function. Director, can you highlight shape and function for me? Shape and you correct. Thank you. Yeah, correct. Thank you. Shape and function. I'm not all that interested in the size, but I'm more interested in the shape and function. So I want everybody to listen to me. They vary in shape and function. So the fingers are elongated. Our fingers are elongated. So the cells should have that kind of shape so that when they are grouped together, it will give a shape to the finger. Eyes are spherical. Let's come to the function. The human eye is to see. The human eye is to see. So the functions of the cells in the eye should help us to see. But the human nose is to smell. So the cells in the nose should be able to have receptors that will differentiate between fragrance, something nice, and something bad. So, and also the cells in the stomach. You see, the stomach is to digest, to break down food. So the cells in the stomach will have the ability to break down food, and then different from the eye. So when we say, cells vary based on size, but I'm more interested in the shape and function, this is what they mean. Today you understand it. They are so small that they can only be seen under the microscope. Within each cell, we also have something called the organelles. Organelles are the tiniest. They also have living function. They survive. When the organelles die, of course, the cell will also die. Now, cells, just like human beings, they respire, they breathe, they eat. The food that we eat go into the cells. More than 100 trillion, they take it. So if I eat kenke, rice, banku fufu, tozafi, more, now all of these are going to be taken by the cells. Because we said cells are the basic unit of life, meaning that the cells must be surviving for us, the human being, to survive. Living cells come only from other living cells. Very interesting. Very interesting. Now, let's look at the diagram. Cells. A cell has three. In fact, if you are dealing with the new book, the 9th edition, you see that there are more. You see lysosome, mitochondria, Golgi apparatus, centriole, etc. Then you see the cell membrane, cytoplasm, nucleus. But these three are the three basic functions, or the three basic parts of a cell. You have the cell membrane that serves as a wall. Now, of the most important is the cell nucleus. That is the brain center, the nucleus. Once the nucleus is damaged, it's just like a human being. Once your brain is damaged or your brain is dead, you are dead. I don't know if you guys know that. Once your brain is dead, you are dead. The same way, the cell, the nucleus. Once the nucleus, which is the brain center, it's the one that coordinates the activities of the cell. And we have more than 100 trillion of this in every human being. The cytoplasm is like a cushion around the cell nucleus within the cell membrane. Now, The cell membrane has passages from where oxygen, when you breathe, oxygen goes into to the cell nucleus, and waste products will also go out. So there are, passages around the cell membrane, which is not shown in this picture, but that's how it is. There are passages where oxygen will go to the nucleus. Now, the nucleus is surrounded and protected by the cytoplasm, the oval shape, the oval structure as the brain center of the cell to direct. Yes, to direct. So that's how it is. Now, let's go to tissue. Now, okay, right there. Now, this is where I want attention. 2 or more, everybody listen to me, 2 or more cells that are similar in structure and function are joined to form a tissue. You see, when we come to organ, we are going to hear that, oh, okay, the organ is there. Let me quickly read the organ. No. That is the system. Okay, it's okay. So let me talk about the tissue. Now, the tissue is that when 2 or more cells, so guys, 2 rounded cells in the eye that will enable us to see when they come together, 2 or more, we call them the eye tissue or the tissue of the eye or etc. tissue. So they must be similar in function and structure. It means that a cell in the finger that is elongated cannot join a spherical cell in the eye because one is spherical, one is elongated. So tissues must come from 2 or more cells, and they must be similar in terms of structure and function. If their structure is different or the function is different, they cannot. Then we have epithelial tissue, then we have the connective tissue, and then we have the muscular tissue. So the epithelial tissue, of course, covers the human body. That's the skin. The skin. Then we have the connective tissue. This tissue supports, stores energy, and connects other tissues, and blood is part of it. Muscular. We're able to move our muscles. Then we have the stomach, an organ as a part. Then we have the skin. Now, let's go down under tissue. I think there is something there under the tissue. Yes, organs. Organs, over there. Guys, you just remember that I said with the tissue, it is 2 or more cells with similar structure and function. But let's read out the organs. Organs are formed when 2 or more different. Look at the word. This time not similar, but different. Different types of tissues are grouped together to perform a specific function. This is the difference. So the difference between tissue and organ is that, yes, tissue is a collection of cells, but they must be similar. If it's spherical for the eye, they must be spherical, and their function must be able to see. They must help us to see. But when it comes to organs, 2 or more different types of tissues grouped together. Now, let me give you an example. Reproductive organ. I want to give you an example for you to understand this. When you talk about the male reproductive organ, the testicle has its job. The penis has its job. So they're not the same. With due respect to everyone, we are all adults. The testicle is not going to enter the vagina. It's the penis. So you see, their functions are different, but they all collectively come together to perform a particular function. Without the testicle, there cannot be sperm also at the end. So there cannot be fertilization. I hope you guys are understanding me. So that is how organs are different from, tissue. Are formed when 2 or more different types of tissues are grouped together to perform. So for a baby to come out at the side of the male, we have all this coming to, but they perform different functions. That's why the word different is here. All right, let's go to systems. So we have cells, a group of cells go to form tissue, then tissues also go to perform, to form organs, but they must be different. Then several organs also now form systems. So let's look at systems. Now, several organs come together to form a system. Good. Several organs come together to form a system. So we have the skeletal system, the digestive system, respiratory system, reproductive system, etc. etc. Now, systems are very much important because they are the larger unit that form the human being. Okay, let's go down for me to see what we have there. I think the first one is the skeletal system, right? Yes. Now, the skeletal system, good. The skeletal system. Now, so we have several systems. One is the skeletal system. Guys, if you want some short break, normally we give some short breaks. I don't know the plans. What are the plans, director? Does the class flow 3 hours, or sometimes there is some kind of breaks?
Now that you mentioned, I think let's leave it to the class. Do you want us to take like 10, 15 minutes break, so that people can refresh? Those who want to pray, those who want to drink, come back. Okay. All right. So I think Prof will hit a point, then we would take a break and agree on that time to be time that we take break, so that people can go refresh, do whatever you want to do for just 15 minutes, then we can continue.
Yeah. I think Shania want to say something, right? Shania, do you want to say something?
No, sorry.
Okay, it's okay. All right, thank you. Okay, so let's go to the skeletal system.
Prof, I think 4:15 we can go, then come back 4:30.
Okay, that's fine.
That's okay with all of you.
Yeah, it's fine. Yeah, it's fine. Yeah. Okay, let's talk about the skeletal system. The skeletal system is very important. We talk about the skeleton. You might not see how important the skeletal system is, but just how many? I believe everybody knows snail. I think I don't know if everybody is a Ghanaian here, so I don't want to go that route, but it looks like most are Ghanaian, am I right? Snail. Everybody knows snail, right?
Yes.
Yeah, we know it.
Yeah, correct.
Yeah.
Sure, thank you very much. If you have ever seen a snail with the shell, broken, maybe it is trying to cross a road and then a car, for some reasons break it. You see that the snail cannot move. It cannot move. It's alive, moving, like kind of shaking, but it cannot move. So what is making the snail to move? It is the shell. Now, why am I bringing this example? This example applies to human beings. You and I are able to walk. As a matter of fact, I am able to talk right now for you to hear me because of the skeletal system, even though the auditory, etc., play a role. You are able to move because of the skeletal system. Without a skeletal system, we cannot move. The body will just be just there, a mass of immovable object that cannot move. So the skeleton is very, very important. The body is just forming around it. It's a flesh that forms around it. Without a skeletal system, see figure 3.2, the body will just be an immovable mass. There are approximately 206 bones. Well, kids, you see, when we are kids, we have a lot of, bones, but at the end, some actually, joined together. We have tendons and ligaments. Can you go up a little bit for me, director? Up a little bit for me, where I was. Yeah, right there, right. It's okay, right there. Now, they are arranged in an orderly manner and are fastened together by tough connective tissue known as tendons and ligaments. I remember 2014, I was teaching this, and then somebody said, "Gru, gru, gru." You know, when you slaughter an animal like a poultry, chicken, you see where the thigh and then the hip, you see some kind of soft membrane, you know, connecting. Yes, those things are ligaments and tendons that we like to chew a lot. They are very easy to, they are not hard like the bones. Now, they are fastened by these tendons and ligaments. Now, the 5 main functions of the skeletal system are allow movement, protect vital organs, produce blood cells, etc. But the allow movement is very key, and they give the body a shape. They give the body a shape. So when you see a skeleton, you can see the skeleton already in the form of a human being. Yes, go up for me, please, director. Good. Go right there. It's okay. Thank you. So you can see the skeleton already there. It's formed as a human being. Anybody who sees this knows that it's not a goat skeleton, it's not a cow skeleton, it's a human skeleton because it's already formed. So the flesh is just going to form around it to give it a shape. And it is this skeleton that you see figure 3.2 that allows people to move. Most bones are made from cartilage, but through a process known as ossification, cartilage is sometimes replaced by bone. So cartilage is a flexible connective tissue that provides framework to the body. It must include support. So cartilage is, I mean, when you slaughter an animal, you can see all this, but you know, some of these things are in animals also, but we are not going to that. Now, so our main focus is to see the skeleton. Now, there are different types of joints. So those things, the tendons, the ligaments, they join, they fasten two bones. They fasten, you know, bones together. Now, if I don't know if you have ever heard from somebody that says that, oh, he or she is going for, let's say, hip surgery. If the bones are meeting, the person will be having pains. So they have to go for, you know, a surgery. They put something there for the two bones not to be meeting, because if the two bones are gliding, you know, the person will be feeling pains. That's how it is. So those are the things that, you know, help bones to be in their position for us to bend. We can bend when people are running, exercise, you know, we can bend, we can move those things. Otherwise, the bones will just be meeting bones, and that will be very difficult for people, you know, and that is very, very critical. Now, we have different types of joints. Let's look at joint. A joint is any place where two bones meet, of course. So hip joint is one, for example, and we have. Can we go up, director? There are some examples at the top above figure 3.3. Above figure 3.3. Above figure 3.3. Right there. Very good. Yes. Oh, almost there. Yes, right here. Thank you.
Mm-hmm. No
Oh,
problem.
he left again. Yeah, hinge joint. Yeah, those joints. Yeah.
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 Go
Let
down.
it come down. Yeah. Oh no, up rather. Yeah, you know, don't mind me. Up rather. Oh, you know where we have those joints. Yeah. Stop there. There are several types of joints. Yeah, stop there, please. Thank you.
Okay.
Yeah, thank you. Now we have the gliding joints. Allow the head to lower. So you see, have you ever asked yourself, how are you able to bend down? How are you able to bend down without feeling pains? Your neck area, because we have gliding joints and they allow us to, to glide, to bend. Then we have the ball and socket. If you look at figure 3.2, the opposite side of where I'm reading, the ball and socket, look around the hip area. It's not showing very well because of the way, but you see like, the tip of the hip area, okay, I think I just have to pull a different picture. It's okay. So ball and socket allows movement like someone swinging the arms. So all this, and then you have the pivot joints allow a turning motion such as the palm. You can move your palm. Let's say you want to do somebody bye 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 bye. The way the palm will be like moving. That's an example. Then you have hinge joints. That also allow us to allow backward and forward bending motions. So these are some of the joints, and sometimes they do surgery on this type of joints, hinge, and then the ball and socket, especially like the hip area, hip surgery, where they do a lot of lessons. Once you begin to age, one thing about skeletal system, very soon we are going to look at the surgical procedures that are associated with the skeletal system. You are going to see that normally it is people who are aging. Well, for example, for a craniotomy, it can happen to anyone. But when it comes to hip, knee, those things, begin to come in with old age. Now, let's go down our place. Yeah, down again. Yeah, bone fracture. Yeah, those pictures. Okay, yeah. Yeah, the box, very good. Figure 3.5, very good. When you look at figure 3.5, you see this an example of the hip joint, which is like the ball and socket type of thing. It is into the hip. I mean the leg, the thigh bone is into the hip bone area. That's an example. Very interesting. When you begin to work in sterile processing, sometimes the OR will call for an instrument, and then you will send something to them, and you see some, procedures. Very fascinating. Okay, let's go down. Okay. Yes, very good. So these are the surgical procedures. Now we are interested in the surgical procedures that are associated with the skeletal system. We have can we go up a little bit? I think when I say up, it's rather the opposite. Yeah. Okay, it's okay. Yeah, craniotomy. Where you have the craniotomy below figure. Yeah, it's okay. Yeah, it's not bad. It's okay. So we have total knee arthroplasty, and then we have yeah, total knee. Then we also have a total hip replacement. When you look at this picture, 3.9, you can really see how the rounded thigh bone is going to fit into the hip bone. In figure 3.9, picture 1, and that is a very good example. And the picture at the left hand side, somebody's toe or foot. Podiatry. I mean, you'll be hearing about podiatry also, like foot. Foot surgeons or doctors also work on those ones. Yeah, let's go and see more. Yeah, please. Yeah. I think it's almost time for our break. Now, total knee arthroplasty is also there. So these are example external fixation. These are all examples. Total hip arthroplasty, as you can see, these are all examples. Yes.
Prof, let me interject something a little bit. Okay. When we are doing the total knee replacement, in the case of people who have come of age and they are having issues with their joint, when they come to the OR, what the surgeons tend to do is that, so this, can you see my cursor?
Yeah, correct. I can see it.
This is the diseased joint. This is the reason why you are having a knee pain, right? Because disease eat the gliding, joints, So once it begins to move, you begin to feel pain. So when you come to the OR, the surgeon will cut the bone from there, then they put an implant called the femoral component, right? When they put the femoral component, then here they put the disc, another disc, so that when you are walking, this implant will be gliding in that plastic, they call it spacer, or so when the plastic spacer and the metal glide, you're not going to have any issues. And with these two implant, we call them implant, is going to be with you for the rest of your life, unless it's kind of miracle. So this is what we call total knee replacement. Your knee is going to be replaced. They're going to cut it as you see in the middle, put an implant in there so that you don't continue to feel the pain. How does this help? As CSPD professionals, they're not going to say, they're not always going to say on the schedule, we are doing total knee replacement. They say we are doing THA. So when you see THA, one, because there's going to be cutting, they're going to need an osteotomy. I mean, they're going to need a cutting instrument, right?
Yeah.
They're going to need some saws. They're going to need some batteries. They're going to need some, devices. These are usually, orthopedic, in nature. So just adding that. All right, Prof.
Thank you very much for that addition. Yes. He has delved into it. Yeah, deeper. Thank you very much. Thank you very much. Yeah. All right. So it's 4:16, 4:16. Let's take our 15 minutes break. 15 minutes. Let's come back at 4:31. 4:31. All right. Thank you, everyone.
Thank you.
Okay, is everyone there?
Yes.
All right.
Yes.
Oh, yeah, that's fine. Okay,
Yeah.
thank you. All right. So it's exactly, according to my time, 4:31. So that is the 15 minutes we are back. Yeah. So before we went on the break, my director was, explaining about that, and it is true. That's about how those surgeries, go on. Now let's go on. Next page, please. Okay. Um, no, not here. Let's go. Let's continue to go. Yeah. The muscular system. Yeah. So when you hear about the muscular system, we are talking about the muscles. When people are playing soccer, football, I'm talking about football. Well, I can talk about the American football also, or when they are running, Usain Bolt. Look at how their muscles pull, or basketball players when they jump. Now, anytime somebody has to walk, muscles must move. Anytime somebody has to walk or somebody has to be in motion, muscles must move. It's only when muscles move that the body can set itself into, motion. So without the muscles, we cannot even walk. That's the interesting thing. Now the bones are there to help us to walk, but then the muscles must contract to move. So the muscular system works with the skeletal system to enable to enable movement of the body or of materials throughout the body. Even as one sleeps, many of the more than 600 muscles in the body, including 400 which are skeletal, are actively at work to keep us alive. For example, heart muscles contract to pump. When we sleep, we are in the dreamland. We are in the dreamland, but the heart is working. What about the chest? The lungs are working. Unconsciously, they are working. We don't instruct them to work, but they are working. That's it. So the muscles play a very critical role. Heart muscles contract to pump blood throughout the body. Chest muscles contract to move air in and out of the lungs. So these are some of the key roles of the muscles. Now, yes. No, let's come down. Yes, we have the skeletal muscles, smooth muscles, etc. Now, there are three types of muscles, or there are three types of muscle tissue called the skeletal, smooth, and cardiac. I want to talk more about the smooth muscles, but before, let's talk about the skeletal muscles. Well, with the skeletal, we talk about it already. These are the bones, the body parts, the legs, the hip, etc. Let's talk about the smooth muscles. They are organized into thin, flat sheets of tissues. Smooth muscles are called involuntary or visceral muscles because they contract and function without our conscious control. And I like this one very much because you don't have to instruct them. With the skeletal muscle, well, you will command them that, I want to walk, and you walk. But with the smooth muscles, they don't need any command. They do not need any command. They work on their own. When they stop working, that means you are dead. So that's why they use the word involuntary. They are called involuntary because they contract and function without our conscious control. They control breathing and the movement of food and fluid in the digestive system, movement of blood throughout the circulatory system, and the movement of of urine through the urinary system. Yes. I know that some of you may argue that, well, if they are involuntary and they act on their own, I mean, you can control urine. Yes, I agree. You can control urine, but you can only control urine up to some point. You can only control it up to some point. When it gets to a point, you can't control it. You pee on yourself. If you don't want to go to the, to the restroom, you pee on yourself. Yes. So you can only control it up to some point. So the urine is an exception, but even that, you can only control it up to some point. So they work on their own. Then we have the cardiac muscles, and also that is like, the heart that pumps blood, etc. You have the arteries and then the veins. We'll be looking at those things. When the lungs taking air, they go into the blood, and then they go to the heart to pump it. So that is about. So these are the three types of muscles. We have the skeletal, we have the smooth, and then we have the cardiac muscle. Okay, let's go. Next please. Yeah, okay, it's okay. So we have the cardiac muscle. As you can see, is similar to the woven mesh, as you can see. Now, we are interested in looking at the surgical procedures that are associated with this kind of things. We have the rotator cuff repair. That is the shoulders. And normally, basketball players and soccer players, well, not soccer players. Soccer players, normally is the hip, the knee, and those things. But basketball players, because normally when they fall on their shoulders. Yes. As if you see figure 3.14, we have normal, and then we have rotator cuff problems. The way it is normal, the way it is. The one with the problem, they drew some arrows, some circles, to let you know that there are problems with that area. Then we also have the anterior cruciate ligament. Rebuilding the ligament in the center of the knee. So sometimes people also, just similar to the one that director explained deeper, knee is a very big issue, and these things come with all age, knee, hip. We've showed that it can happen to anyone, especially the sports guys. Yeah, but those things, if you're young, you'll not be hearing about this. But when you are aging 60 plus, then, 50 plus, they begin to hear about knee surgery, hip surgery, those kind of things. Yeah, let's go up. Next. Okay, yeah, then we have fasciotomy, making an incision. You remember when we were talking about chapter 2, we said we have otomy, ectomy, and ostomy. You see, the otomy is here, making an incision into. Very good. So you see, very good. So the otomy there, in the word fasciotomy, it's a suffix. It's a suffix. Remember, we talk about the prefix, root, and suffix. So the otomy, thank you. Yeah, thank you. Yeah, director. The otomy there in that medical word is a suffix. So right now you see that this is a medical terminology combining root and suffix. There is no prefix over here. This is the reason I said that there is no medical terminology without root, but you can have a medical terminology with a root and suffix, root and prefix. You can never also have prefix and suffix. Never, never. There will surely be, and this is a very good example. And then we saw some examples. So make an incision into the fibrous membrane covering a muscle, usually to relieve pressure from the injured swollen muscle. Then we also have a herniorrhaphy, repairing a cavity wall, muscular layer that's allowing all parts of an organ, to project through the opening. So herniorrhaphy. The raphy there, if you remember, well, I can give this as a trial or assignment. Raphy, what does it mean? You can just go there, back there into, thank you, director, for underlining that. Yeah, it is also a suffix. A suffix. a suffix. So you can, and when you read, it is there. We also have the muscle biopsy. When we say biopsy, actually removing a small sample of, I don't know if you are familiar with biopsy, normally removing, some small part of an organ for medical, examination, etc. Yeah, they can take it from, whatever part that they want. Removing a small sample of muscle tissue for testing in the laboratory using either a needle biopsy or etc. Laparoscopic instruments, can also be used to use. To take some part of, an organ, etc. They can use anything that they want to, that's approved. Now let's go next. Then we have the nervous system. Look at the word nervous. Panic, nervous, panic, including sense organs. Nervous, the word nervous. So the moment you hear the word nervous, I use the word panic just because I want you to understand it better, but it doesn't mean that nervous systems always talk about when somebody's panicking. No, but the nervous system is a fast communication network. It coordinates and creates and carries messages between all parts. Now, what it does is that, look at that, they said to all parts, and I'm going to explain this to you. Now, wherever you are right now at your home, I'm going to give an example. Wherever you are right now at your home, your eyes are seeing things. Now, let me say, may God forbid, you see a snake around you right now. Is the eye that has seen it. The eye doesn't know whether that snake is a good snake or a bad snake. It's a friend or a hostile friend, or it's a hostile thing. So the eye will send it to the brain. The brain is the interpreter. Listen to me very well. The brain is the interpreter. That the brain will say, okay, what you have seen is not a good friend, it's a hostile something, it's an enemy. Then the brain will tell your leg, muscles, move, run. And this thing I've described takes place within a split seconds. Another example, let's assume that where you are right now, you hear pow. Yeah, again, may God forbid. Yeah, gunshot around your area. The moment you hear pow, this time it's not the eye that have seen a snake, it's the ear. The ear heard pow. The pow that you heard, the ear will send it to the brain. The brain will interpret that, no, this is not a reggae music. The pow is not a reggae music. It's a hostile sound. And then the brain will also communicate to the other part of the body. Run, go and hide in your closet. Whatever I'm talking about right now, I'm talking about the nervous system. So I'm going to read something, the fourth line where I'm reading under the nervous system. And to react accordingly, look at that. It coordinates, second line, it coordinates and carries messages between all parts of the body, enables us to be aware of challenges in the environment and to react accordingly. So your reaction about the pow is that you are going to hide in your closet. The reaction of the eye seeing a snake is that you are going to run out and call for help for someone to kill the snake. A complex series of nervous tissues, somewhat like electrical wire, runs from the brain and the spinal cord. You see, the brain is the master interpreter. The eye will just see. The nose will just smell. The ears will just hear. Is the brain. So when you go to the top there, you see, we have two divisions. We have, the central nervous system that consists of the brain. And the brain is, of course, the control unit, as we said, and more than 100 billion. I said this earlier on, that more than 100 billion nerve cells. The body has more than 100 trillion. The body has more than 100 trillion. The brain has more than 100 billion. So the brain is divided into parts. We have the cerebrum, cerebellum, and then we have the brainstem. As you can see in the picture, they are shown over there, and each of these plays a unique function. Next, please. All right. So, yeah, so the cerebrum is divided into two halves, as you can see, each control. So it's just trying to describe, the brain. Each half controls different mental activities and movement on the opposite side of the body, a series of nerve pathways. The cerebellum is located inferior, that's below, and posterior, that's behind the cerebrum. And when you go to the picture above, you see it. Yeah, I don't want the director to go back. It's okay. When you go back to the picture, you see that you have the brain. Okay. He's going there. Yeah. You see the brain stem, the yellow. Look at that yellow thing there. And then look at the arrow. That is, the brain stem. Yeah, medulla, we have the medulla, and then we have the cerebrum, below posterior. That's why they said, it is posterior, cerebrum. Then we also have, of course, the cerebrum, which is the bigger part of it that actually performs the mental work, the thinking, etc. Okay, thank you very much. Let's go down. Oh, sorry. No, pause. Oh, there is something I want to talk about. Now, the cerebrum is the largest part. As you can see in the picture, it is the biggest part. Maybe about 75% of the brain is made up of the cerebrum. Why is it taking a lion's share of 75? Let's see the reason. The cerebrum is the largest part of the human body. The functions manage the nerve impulse that allow us to think, speak, and remember. And I said that already. The mental way, control most voluntary muscle interactions, interpret information, etc., and then influence the foundation of personality, etc. So you see, whatever the human being is doing is the brain. Almost everything is the brain. Okay, down now, please. Yeah, it's okay. Yeah, let's come to the sense organs. Well, the sense organs are very easy. With my experience, students like this. When we say sense organs, we have eyes, ears, nose, tongue, and skin. These are things that the eyes will see, the ears will hear, the nose will smell, the tongue will let you know whether something is sweet, sour, etc., or bitter, and then the skin, if somebody should pinch you, if somebody should pinch you, you'll feel it. The eyes, normally I don't spend much time on this. The eyes is to see, is the vision. And then there are several types, sections of the eye. The sclera is the white portion. Normally we see that from everybody's eye. Then we have the choroid is the middle layer of the eye that furnishes nourishment to the eye via blood vessels. So basically, this area, what we are interested in, as a matter of fact, let me tell you guys, in the examination, in the board exams, they're not going to, in the board exam itself, they're not going to ask you, oh, what is the sclera? What is the choroid? No. They're not interested in that. They may ask you of surgical procedures that are associated with, the sense organ or something. And as I said from the beginning, and I'm speaking authoritatively, chapter 2, chapter 3, and chapter 4, normally you see like maximum of 3 questions each, not more, because these are not things that sterile processing tech is actually going to do on the field. Yes, but when you go to some, for example, chapter 14, high temperature sterilization, there's going to be about 15 questions. Mark my words. So the good thing is that they don't bombard you with a lot of biology, because this is not a biology course, it's sterile processing. Now, next please. Yes, yes, as you can see the eye, these are the parts of the eye. And we also have the ear. The ear is also there. The eardrum, yeah, next place, yeah. Yeah, the nose. Okay, sorry. Yeah, pause there. Yeah, the nose is also there. Is the smell. Yeah, the nose is the organ of smell and consists of many sensory receptors. Yeah, the nose will let you, smell. Oh, this is perfume. oh, this is, oh, lavender, as we call it, perfume or spray, nice spray. Or this is a smell from a carcass, a dead body or something. So these are receptors. Remember, the nose is just, having something in. It's the brain. Remember, it's the brain that will analyze, will tell you that, no, this is a body perfume, nice one. Or this is a dead animal. So again, all and the nose, eyes, they don't interpret. It's the brain that interprets. The cerebellum that we saw is the one. The tank also, the tank, you see, the tank is divided into several portions. At the middle of your tank, when you put something sweet, you may taste it or you may not taste it at the tip. So the tank is also having different receptors. Something that is very bitter, like chloroquine. If you remember, chloroquine, from Ghana, very bitter. But something that is very sweet, like sugar or honey. Yeah, the tank, will smell that. Sorry, I'm sorry, not smell. Will taste that. Then once the tank tastes that, it will communicate it to the brain. The brain will say, oh, this is honey, take more. This is sugar, take more. This is chloroquine, throw it away, run away. That's what it does. So the brain is still connected. And that is why these things are connected to the nervous system, because it's the body electrical system. Thank you. Next one. Oh, cataract. Oh, yeah. Pause there. Very good. So you see, some of the surgical procedures, cataract extraction, you can see figure 3.21, above figure 3.21. When you look at the picture, look at how clouded lens removed, intraocular lens, implanted. So when you look at those pictures, the one at the left-hand side, the tip there, it's so cloudy, so you cannot see very well. But after surgery, cataract surgery, they put implants. Look at how shining, so they can see clearer, better, and that is awesome. So these are some of the procedures that go with, yeah. Let's go on with the eye. Okay, let's come to endocrine. Okay, well, yeah, pause the place. Thank you. Some of the cases that also go corneal transplant, bilateral maryngotomy with tubes, making an incision into the tympanic membrane, to permit fluid to drain. Small tubes are. So these are stympectomy, and then we also have tympanoplasty. Remember, we also store plasty today, which is the plastic there is a suffix. We say it's a surgical restoration. Remember, we talk about hemiarthroplasty. Remember? Yeah. So all these things are also there. Now, let's come to the endocrine. Endocrine, we are talking about hormones. Hormones. Imagine you are very happy or you are very sad. Imagine you are very happy. You won the Mega Million or the Powerball or your dream job or somebody you are dreaming to marry has agreed. Imagine how joy will be. Let's look at the opposite. A job that your whole life is on a job. You just, one day gone to work, then they tell you that we are sorry, we are laying off. Or a dear one lost. These are the hormones. Things will make you happy, things will make you sad. Now, there are hormones, or the body will secrete certain things that will calm us down. That's what we are coming to learn. The endocrine system adapts to changes in the environment. During times of excitement, stress, or when one feels threatened, how does the body react? Chances are muscles tensed. Let's assume that there is a gunshot around you. Pow, pow, right now. Look at how your heart will be beating. You run. Your heart will be beating. Poo, 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 poo. Hormones will be secreted. Hormones will be secreted to calm you down. It's very, very interesting. Now, so these rapid changes in the body functions are set in motion by the hormones or secretions produced by the glands of the endocrine system. These glands and the substances they produce have profound influence on bodily function, such as metabolism, growth, and personality. So, guys, when you are sad, imagine you don't want to eat. You don't want to eat. People are consoling you. By the time you realize, you begin to calm down gradually, 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 gradually. Hormones are working. The endocrine. Now, uh, since hormones are distributed throughout the body, the endocrine glands that produce them are not necessarily next to the organs. It is just like you are having foot pain and they give you a medication to take. It goes into your stomach, but the medication knows that it has to go into your foot. So what happens is that the glands, it doesn't matter what they are. If they know that you are feeling a pain in your toe and something must be released to cure, they will travel there. They know. Very interesting. That's how God has made these glands, the hormones. Now, the paragraph then says the nervous system and endocrine system work together. When the brain interprets, you see, when the brain interprets information as a threat, it rapidly sends out nerve impulses that trigger certain endocrine glands to release. That's the next place. Yes. So yeah. So we have some glands over here: pituitary gland, thyroid gland, thymus, pancreas. Then we have the adrenal glands. The glands, as we said, because they can travel, it doesn't matter. You'll be wondering that we don't have anything in the leg. Yes, because we just learn that they can travel to whatever they are. As I said, it's just like you are having, something in your food and they give you medication to drink. The medication goes to your stomach, but listen, it will travel, fat your food, and that's what happens. Okay, so next place. Okay, yeah, right there. Okay, so we have the major glands of the endocrine system include the pituitary gland. The description is there. What it does that, you see, its secretions also stimulate the skeletal and body growth, development of sex organs, regulation of blood pressure, the reproductive process, and muscle development. So the pituitary gland plays a very key role. Then the thyroid gland is also there. Now, one that I like to talk about more, and then we have the parathyroid gland, and then the adrenal glands. Adrenaline. I believe everybody has heard about that. Let's talk about that. Now, during sudden stress, these glands, which are located on top of each kidney, release adrenaline that increases our heart rate and physical strength. Sometimes we are strong, but we don't know we are strong. Should somebody attack you right now, you might think that you are sick, but you don't know where the energy will come. Adrenaline. Adrenal glands are released that give you energy, the strength. That's what they do. So these are the glands and the makers, Now, let's look at the surgical procedures. Thyroidectomy. Is the ectomy is also there. The ectomy is a suffix again. So you see, thyroidectomy, this is making up of a root and suffix. There is no prefix. Rectomy is also there. Oophorectomy. Anytime you say ectomy, it's a surgical removal. Ocheectomy, you see? Yes. So that is the removal of a testicle. And then we have pituitary tumor resection, removal of a tumor on the pituitary gland, which is located. So these are some of the procedures, surgical procedures that are associated with the, endocrine system. All right. Next one, please. Reproductive system. For obvious reasons, normally I don't spend time on this. I remember when we were in school, even if we were sleeping in class, whenever the teacher comes for reproductive health, everybody wake up. It was a topic that we were enjoying when we were kids, yeah, in school. So everyone in this class knows about the things there already. We have the male and then we have the female. Everyone begins. Everyone begins life as a single cell formed when two other cells join together. So we have male reproductive. Male. Of course, we have the male reproductive system, and then we have the female reproductive system. The sperm you see there is for the men, and then the ovum, the plural ova, is from the women. Now, both sperm and ovum contain rod-shaped structures called the chromosomes, 23 from each parent, making 46. That forms a baby. With the men, we have the testes that are housed in the scrotum, and then we have the epididymis, through which the sperm, travels through the seminal vesicle, the vast difference. So these are all, about the men. Can you go down a little bit? Yeah. Okay. Yeah. 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 Right there. Yeah. Right there. Yeah. So that's.
I'm sorry, you have to unmute yourself, Prof. I was going to mute someone and I muted you. Mike, you need to unmute yourself. You are muted.
Yeah. Okay, yeah, I've done it. Can everybody hear me now, please?
Yes.
Okay, thank you very much. Yeah. Now, so yeah, that's about that. So the seminal vehicle, I'm reading the next paragraph. The seminal vehicle joins with the vast difference to form the ejaculative duct. The semen. What we see, guys. What you see is actually called the semen. I mean, you cannot see the sperm. These are microscopic. Yeah, the semen. But of course, the sperm must be carried in the semen into the vagina. So when during sexual intercourse, that's what happens. Now, the female reproductive system consists of the vagina, a muscular canal, approximately 4.5 inches long, through which a baby passes during birth. Normally, as I said, I like to jump over this because trust me, I know everybody at this level knows about this. It's not something so unique. So let's go down, please. Okay, yeah, you can see some pictures over there. So let's look at the surgical procedures. Yeah, let's look at the surgical procedures that are associated with this. We have radical prostatectomy, removal of the prostate gland using an incision. That's about that. We have hysterectomy, removal of the uterus. Then we have bilateral sanguinophorectomy. Remember, when we started the class on chapter 2, we talk about TH, total abdominal hysterectomy, and BSO. The BSO is bilateral salpingorectomy, a removal of the fallopian tubes and ovaries, the ovaries. And then we also have the marital ablation. Then we have DNC, DSE. We also have the ectopic pregnancy. The ectopic pregnancy is an unfortunate situation. We don't want that to be happening to our women. Yeah, very unfortunately. But sometimes, nature has its own way. That also happens. Removal of the fertilized ovum growing in the fallopian tube, to prevent, complications. Yeah, when it is fertilized, it must descend. It must descend. But sometimes, the growth, it stays there and then, begins to grow. Very unfortunate. Then we also have pelviscopy. Scopy is actually if you study all the if you study the surfaces, that oscopy is visualization. Oscopy to see. Yeah, scopy is to see. Scopy to see. So visualization of the pelvic cavity. So that's also a surface. We have a tubal ligation, cutting and bending. So these are some of the procedures that are associated with the male and the female. But you can see that there are more of the female. Next one, please. vasectomy is also there. Stop there. Thank you. Vasectomy, a surgical procedure for male sterilization and or birth control. Yeah, a surgical procedure for male. Yeah. If a man don't want to impregnate, anyone, they can do their own thing, so that there will not be any. Yeah. Okay. Let's go to the next system. Urinary and excretory. By urinary and excretory, we are talking about the removal of waste. Removal of waste from the system. Yes, we are eating. We take breakfast. We take lunch. We take dinner. Sometimes people eat like 4 times or intermittently. The waste must come out. We drink water. We drink soda, Coca-Cola, Fanta, etc. These are all waste. The byproducts, or the leftover is a waste. The nutrients are absorbed by the body in the cells, and then the waste will go through the large intestine to finally out of the anus. So the urinary and then the excretory system are the body purification system. They purify. I like to use that word. They purify the body by making sure that all waste substances are out. The urinary system provides pollution control by eliminating body waste. This process takes place as blood is filtered by the urinary system. Urine is a water solution consisting of various waste substances that are products of metabolism. It obtains its color from excreted bile pigments and may be a shade of amber, pale, or clear. So urine can be a day that you don't drink much water. You see that your urine appears to be like amber color, like yellow. Yellowish, but when you drink a lot. So that's all that. Now, the kidneys play a very key role. Organs of the urinary system include the following. Then the kidney, the ureterus, the bladder, they clear the system out. They make sure that they clear the system out. Any bad thing out. Next slide, please. The next page, please. Yes. Okay, yeah. You're over here, yeah. So, and then the kidneys also play, well, of course, I said that already. The kidneys, the bladder, the urethra, etc. Now, they all, make sure that, of course, anything waste, must come out. Skin contains, look at the paragraph I'm reading. Let me call it the third paragraph. Skin contains sweat glands, oils, hair, and nails. Dead skin cells form hair and nails. You see? So sometimes we wonder, where does our nails come from? We cut them. Are they inside the body? Today you are learning that the skin contains of, sweat glands and, those kind of things. When they are dead, of course, they form the hair. So I remember a student was asking me some time ago, does it mean that those people who normally don't have hair, does it mean that they don't have dead skin cells? I laughed. I said, of course they do. But some of these things are genetics. Yeah. So that's about that. Now let's go to respiratory system. By respiratory, we are going to talk about the nose, then our lungs. Breathing. That's what we're coming to talk about now. Okay, let's move down, please. Okay. Yes. With the nose, as I said already, we're talking about the lungs, breathing, etc. We inhale a lot of things: dust, odor, nice scent, etc. The nose plays a very key role in this, because that is where the pathway or the cavity is in the nose. Yes, during inspiration, air enters the nostril, and that's what, then through the pharynx. Sometimes, remember, you can close your nose. We call something kata. Ghana, we call it kata. Or even in the US here, we call it like allergies or, etc. Allergies when you have the pollen and then your nostrils block. Sometimes people breathe through the mouth. So there are pathways through the nose to the lungs and also through the mouth, also the lungs. So whatever, but the mouth is not meant for breathing. It's only done as a worst case scenario. It's through the nose. So the nose, the pharynx, is air passes through the throat. Then we have the trachea. When we come to the surgical procedures, we will be hearing about tracheotomy. We'll be hearing about that. So let's talk about the trachea. The trachea divides into two. The trachea. Divides into two tube-like structures. The right, and then the right is called the bronchi, and then of course that extends into the lungs. Now the lungs is the key. Maybe after the nose, I'll talk about the lungs, because it's the lungs that expands, and contracts, and we have air, going in. Now, let me go straight to talk about the samples of surgical procedures involving the respiratory system. Thoracotomy. You see that we have otomy also there. Most of these surgical terms or terminology you have seen so far are making up of root and suffix. If you look at it, root and suffix. This again affirms that you can never have a medical terminology without the root. As I said, the root is the primary. So thoracotomy, making an incision, and anytime you hear otomy, it's also different from ectomy, also different from ostomy. So you have the three of them, very confusing. But when you study chapter 2, you are going to get yourself familiarized with this. Now, otomy means making an incision into the thoracic cavity, that's the chest. Sometimes if they want to access your lungs or your heart, open heart surgery. Yes, they are going to, make an incision, to access your lungs or your heart. You also have thoracoscopy. Oscopy means visualization. Remember, we talk about that. Oscopy, viewing, to view, to visualize. If they want to see something, they can make a minimal invasive procedure or etc. Depending on the procedure, whatever they want to do. Creating a pathway, a cavity, a path to view. Pneumonectomy, removal of the lungs. Tracheotomy, making an incision into the trachea. So these are some of the surgical procedures associated with the respiratory system. And again, we are hearing about so many surgical procedures today. As I said earlier, I am not expecting you just in this class today to master all this. No. It is a practice. With time, you will become, accustomed, or you'll be so much, get yourself familiarized. Myself and our director, we started like you. We just entered into the sterile process, and now we are experts and gurus in the field. One day you'll be like us, mentioning these terms and also, teaching people. So have the assurance. Yeah. Next page, please. Okay. Yes. The digestive system. Yeah. Now we are talking about the stomach. When we eat, digestion begins from the mouth, guys. The moment you put food into your mouth, salivary glands secrete, and digestion begins. Sometimes people think that is when they begin to chew. Sometimes people even think that the chewing is not part of the digestion process. It's only when it gets to the stomach. That's a fallacy. The moment the food enters your mouth, digestion begins. And the pathway that food takes through the whole mouth to the anus is called alimentary canal. Very long, 20 to 23, about 30. Well, it varies. Someone asked me before, do the little people, those that we call the little people, Ghana would say kapope or I just smart type, they also have the same age. And I said, well, body shapes, vary according to the height of the person. Now, the function of the digestive system is to convert food into energy for the body. The human body requires 6 basic categories of nutrients: proteins, carbohydrates, fats, water, minerals, and vitamins. So all these things we eat, and they are going to help us. Now, a few of the components of the let's go down a little bit. Let me give some information. I think it is down. Oh no, sorry, up rather. Uh-huh. Yeah, it's okay. Yeah, okay, yeah. So you see the alimentary canal. The process of digestion breaks food down mechanically and chemically, so it can be absorbed by the body cells or discharged as waste. The pathway, I said this already, the pathway that food takes through the digestive system is called the alimentary canal, or the digestive tract. We call the alimentary canal. And this alimentary canal is about 30 feet long. And that is why somebody asked me, do the little people or the agile smart type of people, do they also have that? And I said, of course, I don't believe, because body, things of sizes, vary according to, so I don't think they'll have that. I don't think so. But that is how, the average person, 30 feet long. And that's very long. You might think it's not long, but trust me, the small intestines are very long. The alimentary canal is approximately 30 feet long and consists of the stomach, esophagus, stomach, small intestine, large intestine, rectum, and then the anus. So the pathway right from the mouth to the anus. That's the alimentary canal, about 30 feet long. Okay, let's go on. Okay, yes, thank you. Now, yeah, correct. So digestion begins from the mouth. As I said, I said that already. The food is softened by the saliva, and then sometimes if there's something that you have to chew, like a yam slice, cocoyam, a plantain, or whatever you chew, if there's something that you have to swallow, like fufu, trust me, the saliva already mixed with it. Begins the esophagus, that's where it passes through, and then to the stomach. The stomach is very important. That is where, it serves as a reservoir, the base where the food goes. And then that's where enzymes, a lot of things are going to happen. Now, let me talk about the small intestine. The small intestines are very, very important. Even though the stomach is also very important, where glands, etc., whatever secretions, enzymes, to break down liquid, where the food is converted into liquid or semi-liquid, called chyme. The small intestine is where the absorption takes place. So for you to have energy, the small intestine is very, very important. From the stomach, the liquefied food enters the small intestine, an organ approximately 20 to 23 feet. This is where the greatest amount of digestion and absorption of nutrients into the body cells occurs. You see? So the small intestine is very, very important. That is where your body is going to be happy. It's only when the food, now in terms of liquid, change into liquid. The solid food is in the stomach. Enzymes, glands, secretion break it down into liquid. They go into the small intestine. That's where the body is going to say hallelujah or hooray, hooray. The body is going to say hooray, hooray, hooray. Going to be happy, going to absorb it. That's where the absorption will take place. This is where the greatest amount of digestion and absorption of nutrients into the body cells occurs. The small intestine is divided into three portions: duodenum, jejunum, and ileum. Bile produced by the liver and stored in the gallbladder, along with pancreatic and intestinal juices, facilitate digestion in the small intestine. So still some kind of digestion, because when you look at the stomach, it is converted into Americans will say semi. So when you hear me say semi, I don't know whether you're born here. So when you hear me say semi, I'm talking about semi. The stomach breaks it down to semi-liquid, and the final breakdown is going to take place in the small intestine. The small intestine plays a very key role. That is where the body is going to rejoice that, oh, finally, I'm having this food. Then the cells, more than 100 trillion cells, are going to be happy that they have food. Next page, please. All right. Yes. Okay. So as you can see, we have a rectum and then the anus, and then we have the gastric bypass. Now, let's look at some of the surgical procedures. The one below figure 3.30. 3.30 is gastric bypass, isolating a small portion of the stomach and suturing part of the small intestine. That's what you see over there. Interestingly, the exams, as I told you, is not about this kind of thing. It's about sterile processing. And when that is what our director also reinforced, that from chapter 5 going, that's where we are going to actually see the things that are not going to bring a person's stomach and ask you, but no, they don't do that. But as I said, you are going to get about 3 questions on each chapter, those small chapters. And even one question can be a game changer. 105, congratulations, you have passed. 104, we are sorry you have failed. So no matter how, you must try to take everything very serious. Yeah, I have taught tons and hundreds of students, and some are in the States, different places. No, come down a little bit. I think you jump over something. Page 60, over there. Stop, please. Thank you. Appendectomy. Removal of the appendix is also there. Parodectomy is also there. Gastrectomy. And again, you see ectomy. Ectomy, and the ectomy. You see, surgical removal. You see, otomy means make an incision into. Ectomy means removal. So you must be familiar with this. That is why you must go back to chapter 2 to learn about the prefix and then the suffix. For the roots, it's the primary meaning. So that will not change anything as such. But the prefix and then the suffix. All right, thank you. Next, please. Yes. So when you see that picture, 3.32. As you can see, they tie something up. Yeah, adjustable gastric. We are not medical doctors, so you are not all that interested in this. You are interested in the surgical procedure, which is cholecystectomy, for example, removal of the gallbladder with a surgical incision, or by endoscopic surgery called laparoscopic cholecystectomy. Sorry, we call that lapcoli. So when you are working in the surgical or SPD, so lapcoli. That's what laparoscopic cholecystectomy. Now let's talk about the circulatory system. Circulatory system, we're talking about the movement of, circulatory system is the body's primary transportation network. It delivers nutrients and oxygen, and this is accomplished. Now, one thing I ask my students to do is this. Everybody, wherever you are, Google the distance from New York to Accra, Ghana for me. Tell me the miles. Everybody, please, live assignment. I do this in every class. Google in miles the distance from New York City to Accra, Ghana. Yeah, has somebody got it?
Yes. That's
how many miles?
That's 5,121.7 miles.
Thank you. So it's about 5,100. Let's say 5,200. Now, guys, look at New York City to Ghana. When we take plane like Delta, it's about 10 hours going and 11 hours coming. A plane cruising about 550 miles per hour above 30,000 feet altitude. Look at the speed and look at the distance. But human blood travels 60,000 miles in our body. More than 12 times, about 12 times of Ghana to, JFK or New York to Accra. New York to Accra about 12 times. Guys, as you sit down right now, that's the distance blood is taken. You can't believe it. Very incredible. Maybe across the globe. So the circulatory system is the body's primary transportation network. It delivers nutrients and oxygen to the body cells and carries away carbon dioxide and harmful waste products from them. This is accomplished as blood is pumped through 60,000 miles of blood vessels in the body. You will be wondering, come on, your height is just about, let's say, 5.7, 5.8. 5.5. How come blood is traveling? Yes, it is true. Just use a small needle to punch your palm, your skin, you see blood is coming out. So vessels are everywhere in the human body, guys. So they calculated all this, and that amount to about 60,000 miles, about 12 times the distance, of New York City to Accra. Very incredible. That's the way blood is doing in our system. God is very wonderful. Allah is very wonderful. Now, so that is what happens. Now, we are going to study something about this, circulatory system. Now, let's go down. Let's go down. Next page. Okay, yeah, it's okay. Yeah, so you see, as I said, blood vessels are everywhere. Everywhere, blood vessels are everywhere. Now, the circulatory system also, plays a role with the heart. We have the arteries, we have the veins. The vessels that carry blood away from the heart are called the arteries. The veins carry blood to the heart. Now, let me tell you what happens when we breathe. When we breathe through the nose, we carry oxygen into our lungs. Now, this oxygen gets mixed with the blood. When they mix with the blood, remember the cells, 100 trillion cells making up the human body and 100 billion making the brain, they need oxygen. So when we take, breathe in oxygen, they mix with our blood. And then they are carried to the heart. The heart will pump it to all the cells. Cells have oxygen for you. When the cells take it, take the oxygen, then the blood becomes deoxygenated, meaning no oxygen. Then the arteries will carry it back. The arteries. So we have veins and then we have arteries. The veins carry blood back towards the heart, then the arteries. So when they are mixed with oxygen is very key. Without the oxygen, every blood cell, I'm saying blood cell, every human cell will die because they need oxygen. So we have the vessels that carry blood away from the heart are called arteries, and then the veins carry it to the heart. And so you see that the respiratory system functions in conjunction or in unison with, of course, the heart. It's very, very key. It's very, very key. So if you are in an area, if you're in an area that there is no much oxygen, then there is a problem. You have the capillaries, the tiny vessels abundant throughout the body. As I said, just pinch yourself. Anywhere you see blood out, anywhere of your body, unless it is the nails. So the 60,000 miles we talk about, it is true. Scientists have calculated it, and that's that. The heart consists, so that's what the heart, does. Pumping, boom, 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 boom. The heartbeat. When you go to see your PCP, they check all that. Your heartbeat rate. They can tell you it's about 60. Well, if it is 60, I think it's very slow. I think it functions more than, well, I don't know. But I think it is normally around 70. Well, I don't know the standard, but around there. So that's what the heart does. To carry oxygenated blood to the body parts and then return the deoxygenated ones back, and then for oxygen to go through. Next slide, please. Next page. Yeah, you see the external anatomy of the human heart. I believe everybody has seen the human heart before. It's not anything new. We are not. In fact, we are not typical biological. We are not in the medical school to learn. I mean, like how to deal with this. We are more interested in the surgical procedures that go with, of course, the respiratory. So let's go down. Let's go again. The next place. What do you have? Examples of the surgical. Very good. Examples of the surgical procedures involving the circulatory. Tonsillectomy, removal of the limb. That's also the we have a pacemaker. Sorry. Yeah, pacemaker. People who have heart issues, some of them have pacemakers. It's more electrical medical device implanted in a patient to make the heart beat regularly. We have all that. This is about all that. We have the tonsillectomy, and then let's go to the next page again. I'm sorry. Yeah. It's okay. Yeah. I think we have. Yeah. I think we jump over some of them. We have a. Carotid, let's come down a little bit here. Over there. Very good. Thank you. Adenoidectomy also is there. Adenoidectomy, removal of the tonsil tissue at the end of the soft plate. You also have arteriovenous fistula, suturing the radial artery and cephalic vein together. These are all medical procedures. Aneurysm repair, abdominal aortic aneurysm, removing a weakened balloon-like area in the aortic and replacing it with a synthetic product. Yeah, we have all this. When you begin to work in busy hospitals, you will be familiar with all this. Hemorrhoidectomy, hemorrhoidectomy. Ectomy is also there again, telling you about the suffix ectomy, removal of swollen, inflamed veins from the anus. Yeah. Coronary artery bypass graft, CABG, removal of a vein, usually from a lower limb, to bypass the blocked section of the coronary. When there is an artery that is blocked, they create a bypass. But just like you are driving, and let's assume there is accident in front of you, and then they make a detour that will pass around there. So it's just like a detour, that's what we call it, a bypass, for heart to be very strong. Yeah. Next one, please. Yeah. So basically, guys, as you can see, chapter 3 is also very interesting. I can summarize everything that we talk about. We started this chapter also by talking about cells. You remember that cells are the basic unit of life. If more than 100 trillion cells die, you will also die. It is because the cells are alive. That is why you are also alive. Our life is dependent on the cells. In fact, I want you to understand this. You might think that, I am alive. No, it's because the cells are alive. When the cells die, because your whole life is dependent on the 100 trillion cells. Now, the cells also have smaller units called organelles. But we didn't go into that much. Now, these cells vary in structure and function, remember. And I said the eye cells, in terms of structure, should be spherical because the eyeball is like an egg. Then the finger is elongated, and therefore the cells should be kind of elongated in structure. And in function, I said, the eye is to see, the nose is to smell. So the cells in the eye and the cells in the nose must be different. Then we move on to tissue. We said two or more cells with similar function and structure form tissue. But when we came to organ, I said two or more tissues that are not similar. That's the word I use. Form organ. That was when, because I wanted my students to understand the difference between organ and tissue. That's when I used the reproductive system as an example. And I said, the cells in the testicle, the testes, should be different from the penis, even though they form one. I want you to understand this, because students get confused about the definition of organs and cells. Sorry, tissue. So with organs, not similar, but when they're grouped together. But with tissue, they must be the same. Then we have system. System is a collection. So we talk about the skeletal system. That's when I was using the snail and one snail as an example, that the shell around it is its skeleton that helps it to move, to set into motion. Without the skeletal system or the bones, the human being will just be a mass of immovable mass of structure that cannot move. And the bones are joined by ligaments and tendons. You talk about all this. We look at the surgical procedures that are suited. Then we talk about the digestive system, the alimentary canal of about 30 feet, about 30 feet long, right from the mouth to the anus. We saw that digestion begins from the mouth, where saliva glands, etc., secrete, and digestion begins through the esophagus, through the stomach. Stomach is where the food is broken down to semi liquid form and transferred to the small intestine, the liquefied or the liquid form. That's where the absorption takes place. That's where the body is going to be happy. Then we talk about the nervous system. With the nervous system, we talk about, nerves, the brain, the communication, where I talk about the gunshot, pow, pow, or you see a snake. The nervous system, the ears hears the pow, pow, and then it conveys to the brain. The cerebrum that contains that forms about 75% of the whole brain, is the master interpreter who interpret and tell the body that no, this papa here is not the reggae music, it's a very hostile. Somebody is about to shoot you, run. And then the muscles will contract and move on the skeletal system, then the body, you run. Now, we talk about the sense organs, and we talk about the ear, the ears, the nose, etc. We talk about all that. We talk about the reproductive system. We talk about the male, then the female. I know very well. I rushed through that because I said it is the fundamental biology, and everybody knows about the male reproductive system and then the female. And then also we talk about the respiratory, the breathing. Then we talk about all that. With this, we have finished with chapter 3. If you have any questions, feel free. Director, if you have something to add, you are at liberty to add.
Thank you so much, Professor Michael. That was a very comprehensive treatment of this topic, and for that matter, a very good session. I know we have said this multiple times. Most people, when they enroll in this course, chapter 1, chapter 2, before chapter 4, they just put the book aside and they say, oh,
yes.
I skipped college, because I wanted to do, some job that will give me money, equivalent to going to college. But why am I still being forced to take days, but the good days are ahead of us, guys. Let's persevere. Let's do the hard work. There's no one who has enjoyed anything that's sweet or something that you can write home about without put in the work. Like I said, topics like this, we don't have a lot of questions that come from it. However, we need to know. Knowing this, gives you some kind of bargaining rights, or bragging right. When you are working and you begin to hear some of these things, you are familiar with them, or it's easy for you to understand because you have been trained, you've gone to school, and you've read about it. And topic like this, if you feel like reading the book would be tedious. That's where you do a lot of question and answers, and that would help you pass at least the exams. Then later, when you start working, some of these things will become familiar to you. Without any question, is anybody here who has any issues with getting on the website to do their homework? I know this morning I have helped a lot of people, and just a few minutes ago I helped, I think, the last one. Most of you did the homework more than once, which is good. If you do one and you get 80, you get 89, you get 90, that is not 100%. Let's cultivate the habit of excellence. This job is about excellence. You don't want to go to work, then you clean instrument and we're like, oh, this is just a small hair. That small hair can, become a big issue for you and for that matter, the patient. It's excellent.
Yeah.
If you get 50, 60, 199, listen, do it one more time. You have about 5 trials. You have 5 tries, so do endeavor to get 100% and try to do it before next week. You have 1 quizzes for each chapter. So this week we have treated or gone over 3 chapters. So which means you should have 3 quizzes and 3 practice exams. That should be enough for you. And also, you're going to have to read the next 4 chapters for next week. So this is not just like a get quick scheme where you just show up and you pass your exams and go. You have to put in the work, ladies and gentlemen. You have to do your part. We are here, we can't go through the book, but we are giving you the abridged version of it. We are interpreting, some concepts, in there, and the question and answers will do the rest, and your reading will also perpetuate your understanding. Thank you so much for coming for today's session. We promise that we are going to be respectful of your times. Yesterday we went a little bit overboard being first time and we had to do introduction and all of that. Moving forward, we promise that no matter what happened, we're never going to go past 6 p.m. Even if we are in the middle of the session, we're going to stop so that you can you can just go because you have other engagement or responsibilities somewhere you have to attend to. Thank you so much. Without further ado, I'll hand over the mic to anybody who wants to speak or the professor.
Well, for me, I don't have anything. I just want to say thank you. It's been a pleasure to meeting you guys. Myself and my director are really poised to help you guys succeed. So this can be a game changer about your life. I entered into this career field 2010 and I've never regretted. Whatever I'm doing, I'm still doing SPD. I just introduced myself as being a lecturer at the Yeshiva University, but I'm still in SPD. Working. I mean, you can't just be, listen, you will never be jobless and you will like it. So join us. Please have a profession you will never regret. All right. Thank you.
Yep. And I also mentioned yesterday that I also am a certified network engineer with CCNE and CCNP. And everybody here knows that, that's like a money-making, industry. But
sure.
If I compare what I'm making in this career versus what, people make in IT is the same thing, so I don't see a reason why I should leave here in any shape or form, go start over again, somewhere. So I'm here, I'm still, practicing. I am still licensed, to do, networking and stuff like that, but I'm still here, guys. So take inspiration from, both of us and persevere, go bend the midnight candle and let's see you perform. The good thing about your path crossing with us is that we are still in the field. I oversee 3 hospitals. I have a lot of connections within the New York and New Jersey arena landscape. You have no idea how I can help you get a job. You have no idea how I can speak, in your favor and those who are hoping for you. So just do your part. I promise you, it's gonna be fine. All right.
Yeah.
Thank you so much for coming. See you Saturday.
Thank you very much.
Thank you very much.
Hello.
All right.
Hello.
Thank you.
Salim.
Hi.
Thank you very much.
You're
Thank you.
welcome.
Hi, Mr.
All right.
Salim.
Hi, Mr. Salim.
Hi, everybody.
I'm
Hey,
having
Gypsy.
problem with the question.
Yeah.
What do you call it? The question area.
Thank
you.
I have a question. You can stay behind. The rest you can go. And all those who are also
Okay.
curious problem they might have, you can stay behind and we'll go through together. I'm here for you. All right. All right. One after the other. I know. Is it Shauna or who? I heard a voice that I wasn't familiar with. Who?
You see?
All right. Let's start with Yusuf. Then we go to Gifty. Yusuf.
Okay, I'm just having a problem with the what do you call it? The quiz question
If any
question area.
question you have issues or you have difficulties entering.
Yeah, I'm having
login.
difficulty entering the.
Okay, so now let me see what's going on the back end. And guys, this is going to be very brief. I mean, snappy. Don't leave. I will make this fast.
All right.
Let me stop sharing my screen. That way nobody will see my password and later get visited. Stop sharing. All right, never mind. CSPD and staffing. All right. Yusuf Muhammad, right?
Yes, please.
Okay. I know I saw you. Okay, there you are. Okay, Yusuf, your username is Yusuf.Muhammad, Mohammed, Muhammad. And your password, let me see, reset your password. I'm going to give you a default password, like the one that we assign to everyone who joins the first time. And you can decide to change it so that, no one can log in. All right. Updates now. Oh no. All right, updates. Go here. Updates now. All right, Yusuf, try now. Let's see.
All right.
Who else? As he tries. Jello, did you say you had issues?
Me, Gypsy.
Oh, Gifty. Okay, Gifty. Gifty. It's. All right. So Gifty, yours.
Yeah.
Okay. Uh,
I did the quiz. Can you see my score?
oh yes, I did. Yeah, I saw your score. That's good. Apart from
Okay.
that, do you have any
No,
issue?
I'm trying to do the practice and it takes me back to the quiz again.
Oh really?
Yeah.
Let me see chapter 2. Let me see what you're talking about.
No, not chapter 2, chapter 1.
Chapter 1, and it took you back. What do you mean by it took you back? I saw your score.
No, chapter 1, we have quiz, practice, and bonus.
Correct.
I did the quiz and I'm trying to do the practice, but it takes me back to the quiz again.
All right. All right. So you want to do the practice for 1. Let me see if anybody tried it. All right. And it's supposed to be how many questions? Let me see. Chapter 1, practice 1, publish. And let me see how many questions we have here. All right, Gifty, I don't know. 4 people have already done that. I see that Tofik has done it. Jawara has done it. So I don't know what your issue is. All right. You shouldn't have any issue, Gifty. Just try it again when you are. Okay, let me share my screen so that Gifty, you may have to stay behind. Then we will do it together. Okay.
Yeah, okay.
All right. Don't go unless you have to. Haji Akis, you have issue? You have an issue? Okay. Amda, you have any issue?
I am.
Helen. Okay, Helen. Helen, do you have any issue?
Yes, I tried logging in and it says my username is not registered on the site.
Okay. Try your email, right? Ofori, is it OforiNel7?
Yeah.
Use that
Yes.
as your username. Let's see. Don't write the entire email address. Write OforiNel. If you have any number, add that number.
Is it
Then
all small letters?
yeah, for username usually it's not case sensitive. It's only if the password that's case sensitive. But try that. If it doesn't work, then the Ofori, of course, would be uppercase O.
Okay.
You see if it's your issue resolved.
Mhm.
Come in, hold on.
Ellen, did it work?
Yeah, it worked.
All right, good.
Thank you.
You're welcome. Now you can do the rest of the quiz. Amda, is Amda here? Ajakis, are you
Yeah.
here? Okay, Amda, are you having an issue or you just hanging by? Okay. Yusuf, try logging in
Yeah.
before. Did it work?
No.
So let me see one more time. All right, you see if your username is Yusuf.Mohammed and yeah, not Mohammed. Your email address is yusufdada@gmail.com.
Yeah.
And I'm sending you a link. It's going to come from webmail. It's a password reset link has been sent to Yusuf. Check is going to come from webmail, and you can click on the link and set your own password. Okay.
Okay. Thank you.
I'll still be on if it doesn't work. We have to solve this today.
All right.
Did you get an email?
Yeah, I just received it.
Okay, good.
Okay, thank you. I have it.
Thank you. I'm happy to hear that. That's the relief I was waiting to get.
All right.
Now go do your quizzes, okay?
All right. Thank you very much.
No problem. Okay.
Good, good,
Right. Gifty,
good night.
Yeah, hi.
how we doing? Are you okay? No?
No,
All right.
not.
What is the issue?
I did the quiz and I want to do the practice, but it keeps taking me back to the quiz.
Are you using phone or computer?
No, my phone.
All right. So close all the tabs and log in again. I'm sure you'll get different response. Different screen. Okay. So sometimes we're doing it on the phone gives you this kind of issues. But if you close all the tabs, sometimes when we're doing something and we stop and we come back, when we try to log in, it takes us back to the old screen, But if you clear all your open tabs and you open again, it gives you a new interface to work.
Yeah, okay.
Yeah, try that. If it doesn't work, you can text me. Or I'll
Okay.
make sure everybody, because I'm positive that it is working because some people have already done this. So that means the problem is only peculiar to you.
Okay, I'm gonna turn off my phone and put it back on and see.
All right, no problem. You can reach out if you have any issues.
Okay.
All right, then
Thank you.
you're welcome. Okay, bye. Ajake, do you have any issue? Do you have any issues? All right, then I'm going to end the call now. See you on Saturday.
Hello?
Yeah, Charles, I'll call you right now.
All right.